Okay, so here we are. 4.2 B is in boy, beta, Bravo, composition of functions. Okay, so what they kind of start out, to me, they start out backwards here, but I'm gonna kind of go a different direction here. Not really a different direction, but more of I'm gonna start with their orange juice story here. Okay, so we have two machines. We have machine 1 that makes orange juice. I have machine 2 that cans the orange juice. And then I have, well, I don't have, sorry, an orange pen. So I've got all these oranges that are going in here and being squished into orange juice. Once they come out of here, they're poured in here and they're put in orange juice cans. Okay, so we have two things happening. We have two functions happening. Function 1, oranges into orange juice. Function 2, orange juice into cans. All right, you can't switch those around. You can't put them into cans first and then make orange juice. Okay, so you have to follow this reasoning here. So what happens is you have to make, and let's call this our first function. Okay, our function of machine 1 is to make orange juice. Our second function is to put them in cans. Okay, so we have two functions. So what we have here, I'm going to make this a little smaller here. Okay, so the key question here is which of these two do we do first? We do that first. Okay. Then we do this part here. Then it goes into a can, which then looks like that. Okay, so this is what the formula looks like, or the method looks like. Okay, now it looks kind of odd because the g comes before the f of x. But what happens with, if you remember from way back when, order of operations says we do what's in the parentheses first, which means we're going to do that first. Okay, so basically what we're doing is we work from the inside and we go out. Okay, we squeeze the oranges, then we put them into cans, and that's what it's saying there. Okay, and this is also written another way. A little circle and an F, and this means g of f of x, and this is what this means. And what I suggest doing is when they give you a problem that looks like this, rewrite it as, so you know, function of x, and once you get that, function of g. Alright, so let's try a couple of these and make sure we've got this down. I'm going to skip the part on the composite of functions on page 266, 267, because they're showing you changing from Fahrenheit to Celsius to Kelvin temperatures, and really if you just follow what I'm doing with these here, you'll be just fine without having to have that example. Alright, so find the following composite function outputs. This is example 6. So they give you your functions. Okay, they give you f of x, which is 2x minus 5. They give you g of x, which is 6 minus x squared. And then they give you h of x, which equals 1 over x. Okay, whoops. See if I can write that correctly. Okay, so there's our functions. We're not going to use all of them in every problem here. You're just going to have to kind of pick and choose, because A says h of f of x. Now remember what I said? Write this as that first. So f of x is 2x minus 5. So that says whenever you see an f of x, you're going to put whatever f of x is here, 2x minus 5, into h. Okay, so look what happens here. I'm going to take my f of x and write it down, and it says, oh, now look at h and put 2x minus 5 in whenever you see x. So I've got an x there, and instead of x, I'm going to put 2x minus 5 there. Okay, so I have 1 over 2x minus 5. All right, next question is, what is the domain? What numbers can x be? Well, x cannot be a number that makes this denominator 0. So we have to find out what makes that denominator 0. So 5 halves. So x can be any stinking number in the whole universe except 5 halves. So when they ask you for the domain, that's what you're going to say. All real numbers except 5 halves. All right, so let's keep going here. B says, I've got f of g of x, and again, I'm going to write it as f of g of x, just because it makes it easier for me. All right, so I've got a g of x right here, and it says I'm going to take my g of x, and wherever I see an x in the f part, I'm going to put 6 minus x squared. So it's 2 times 6 minus x squared minus 5. So see what I did? I just replaced the x with 6 minus x squared. Given me 12 minus 2x squared minus 10, which is negative 2x squared plus 7. Oops, that's a 5. What am I thinking? Sorry about that. Okay, so that's plus 7 there. All right, so the C part of this says g of f of x. Okay, and that is g of f of x. Now notice here, we just did an f of g, and now we're doing a g of x. It's not like multiplication where 3 times 2 equals 2 times 3. You can't switch the order of these and get the same answer. You're going to get 2 different answers here, almost always. All right, so let's look at this. I'll get some red ink here. I'm going to take my f of x, and I'm going to take that and move over to the g, and wherever I see an x, I'm going to put 2x minus 5. Okay, so let's go ahead and do that. So I'm going to take my 2x minus 5 and put it wherever there is an x. Okay? And that is not going to be very pretty here, because we've got to square that. And then we combine our like terms here, and we end up with 4x squared plus 20x minus 19. Remember to distribute this negative all the way through there. And that's what you get, which is a ton different than what we got here for our f of g. Okay, so again, not really a lot of similarities there. Now, example 7, they are using the calculator for this. I'm just going to kind of show you real quick how to do some kind of different ones by hand. Now A and B show some real simple ones, so I'm just going to do A, and then we'll jump down to C because it's a composition. Alright, so F plus G. Okay, so you're just adding those, but when you're using a calculator, it's going to give you an actual graph. Alright, so let's look at C. It says compute this. And again, I'm not going to use a graphing calculator for this because it's real easy just to plug the numbers in. And what they've done is they're not using x here. They're using -3 here. And then this will be -3. All right, so what does that mean? That means that g of -3, we're going to put -3 in there. So 2 times -3 squared minus 4 is going to be 14. Okay, and now it says we're going to take that 14, because we got it there, and wherever I see an x here, I'm going to put my 14. Okay, so then that gives me 3, square root of 9. Okay, so that ends up being the answer to that. Okay, so that should be it. You know, I only did one of these that they actually gave you a number, because when you get to ones like 21 and 22, 23, 24, they're going to give you numbers. It's done the exact same way that I just did this one. In fact, got a little bit of time. Let's go ahead and pick one of these here and just kind of look at it. So like number 22. Let me pause here. Okay, so there is number, I guess it's 21 that I have here. Okay, and this is the A part. Alright, so this is F of G of 2. Okay, so I'm going to put 2 in here. Okay, so that's G of X. Okay, now I'm going to take -1 and I'm going to do the F part. So I'm going to put the -1 there. And then my answer is 2. Okay, really not that hard, but it can get confusing following this and kind of understand what's going on there. But that is it for lesson 4.2.